Okay, here we are, continuing on in the first section, 8-2, day 2. And today, all one kind of problem, we're going to be finding critical points algebraically. So, let me give you a definition for a critical point. Critical points on a function happen at x equals some c value. Let's see. If and only if f of c is defined, so there has to be a point on f at this particular spot you find, and this is what's key. The first derivative of that c value either equals 0 or the first derivative of that value is undefined. So if the first derivative is 0, we'll have a critical point, and if it's 0, we just learned that that critical point is either going to be a max, a min, or a horizontal plateau. If it's undefined, we either have a cusp or a vertical plateau. All right, and we're also going to be finding critical points on the derivative function. So, critical points on the first derivative function happen at c if and only if f prime of c is defined and the second derivative equals 0 or the second derivative is undefined. So if the second derivative is 0, that means the first derivative had either a max or a min or a horizontal plateau. If the second derivative is undefined, that means the first derivative had either a cusp or a vertical plateau. So these don't tell us anything about the original function. It tells us things about the derivative function. And we did not do that in those tables yesterday. So today's problems are all the same. They ask you to find critical points on the original function and its derivative function. So we've just got to do these 4 things algebraically. All today, well, algebraically with calculator at the end. So just, I think, 3 or 4 examples, and they're all the same. Find critical points on f of x and f prime of x. So, here we go. Start with f of x equals 6x to the 5th minus 10x cubed. Okay, so I'll start by finding critical points on f of x. And we do that by setting the derivative equal to 0 in the derivative, and we're going to check to see if it's undefined anywhere. So let's find the first derivative. So doing derivative, a little power rule here, 30x to the 4th minus 30x squared. So in order for there to be a critical point on f of x, this function here has to either equal 0 or be undefined. Okay, let's work on the undefined. We're going to do it algebraically, so we're going to factor. Think of the 2 baskets. I can take out a 30x squared from both of them. And if I do, that leaves me with an x squared minus, this whole thing is coming out, but I need a placeholder there, and that's a 1. So now I've got a product of zeros. If you've got 2 things multiplied together, thing 1 times thing 2 equals 0. Well, think about it. What when you multiply and get 0, one of these two things has to equal 0. Either that has to equal 0, or this has to equal 0. So I set those two things up. This is Algebra 1 stuff here. 30x squared has to equal 0, or x squared minus 1 had to equal 0. While solving this, divide by 30. X squared equals 0. Take the square root on both sides. X equals 0. So we know we've got a critical point at 0. Here, solving this, I'll add 1 to both sides. Now I take the square root of both sides, but I got to remember there are 2 square roots for every number. There are 2 numbers squared that give me 1. I can square 1, or I can square a negative 1. Positive or negative 1. So I've got 3 critical points. And at this point, I don't know whether these 3 values are maxes, mins, or horizontal plateaus. And I'd like to do that right now. Identify what these critical points are. And I'm going to do that with that number line graph that we did yesterday. So we'll make our own number line graph. Even though I could easily graph this at the beginning here and tell what these are, I don't want to go that way. So I've got 3 critical points. If I think about the number line, I'll go negative 1, 0, and 1. Oh, I should check my undefineds too. If I look at this, undefined, we get undefined when we divide by 0. Well, there's no denominator here, so there's nothing that's going to make this undefined. We'll have one in the next example, but again, to be undefined, we want a number divided by 0. Well, I don't have a denominator here to worry about, so there's nothing here. So there's no solutions that make it undefined. So I don't have anything to worry about there. All right, back to my number line graph here. I've got 3 critical points where they all equal 0. The derivative equals 0. So I need to know what's happening with my derivatives in terms of positives or negatives in these 4 spots in between. Well, I'm going to use the table to do that. And again, I want the derivative equation typed in, not the original. So if I type in the derivative equation, it doesn't matter which one, with the parentheses or without. I'm going to choose without. I'll go to the y equals 30. And don't fast forward through this, you need to pay attention. Minus 30x squared. Now go to the table set. And I want to look from negative 1 and in between all of these. So I'll have it start at negative 1. And I'll go by 0.1. So, table. Now if I examine the graph, there's my 0. I want to know what's happening with the y values before negative 1. And all I care about is the sign. These are all positives. So that means I can fill a positive in here. After the negative 1, they're all negatives. So I can put the negative here. Now I got to get up to the 0. Okay, after the 0, again, I can see there's still negatives. And then I got to get to the 1. And then after the 1, I'm back to positives. So now I know exactly what these are going to be when I fill this in. Original function was increasing. Then it decreased. I know I've got a max here. It was decreasing and it still decreased. Here I know I've got a horizontal plateau. Plateau. And then it increased again here, so it went down, then back up. Here was a min. So I've been able to identify what my 3 critical points are, all by the derivative function. Not even graphing the original, which we could have. The only one we probably would have missed was this plateau. Might not have seen that in the graph. Okay, that's half the problem. I found all the critical points on f of x. They also want me to find the critical points on the first derivative. Well, again, I've got to check the second derivative to find critical points on this one. So I'm going to try and squeeze that in here. I'll go critical points on f prime of x. Do that work right here. So I want the second derivative. So I will use this one here. That will give me 120 x cubed minus 60 x. I want to set that equal to 0 and check and see if it's undefined anywhere. I'm going to squeeze in the equals 0 right here. I'm going to factor out the 60x. That will leave me with a 2x squared minus 1 equals 0. Set each factor equal to 0. So here, divide by 60, x is going to equal 0. So I've got a critical point at 0 on f prime of x. Here, if I add 1, divide by 2, divide by 2, and then square root both sides. And remember to do the positive and negative square root of 1/2. I've got 2 critical points there. So here I found 3 critical points. Do I know whether these are max, mins, or inflection points? No, and I'm not going to make you do the second table. I'm only going to care about the first function here. You understand this? I know you can do it over here too. So we're just going to do the one table, and we're just going to identify these critical points on f prime of x here and be done with them and not identify exactly what they are. As far as undefined, there are no denominators to worry about, so I know it's not going to be undefined anywhere, so nothing to check there. Okay, this next one will have some undefineds in it. Number 2. Let's see, we've got f of x equals x minus x to the 2/3. Okay, we want to find the critical points on f of x first, so we need the first derivative. So f prime of x, derivative of x is 1, minus, this becomes 2/3, x, subtract 1 from that, so subtracting 3/3, if you need that, you get x to the negative 1/3. Okay, I need to know, when does this thing equal 0? And when does this thing become undefined? Alright, so solving the equal 0 part. Now these negative exponents, let me subtract 1 first. Subtract 1 from both sides. Negative 2/3 x to the negative 1/3 equals negative 1. Get rid of the negative 2/3. So I'm going to multiply by a negative 3/2. So I've got x to the negative 1/3 equals a positive 3/2. Okay, be careful with the negative exponents. I want you to get rid of the negative exponents before you start raising to powers. So this becomes 1 over x to the 1/3 equals 3/2. Okay, at this point you can do a couple different things. I'm just going to flip both sides over, or you could do cross products. But if flipping both sides over is perfectly legal, I'm going to go there. So I get x to the 1/3 over 1 equals, flip this side over, I get 2/3. Now I'm ready to solve for x. So, and what I'm going to do is raise both sides. If I raise this to the 3rd power, that's going to give me an exponent of 1 when I multiply. So I got to raise this side to the 3rd power. So that gives me x equals 2 cubed is 8, and 3 cubed is 27. 8/27. Okay, so I've got a critical point there, and it's the only one I've got where it equals 0. Undefined. Again, undefined is when the denominator comes out equal to 0, because you can't divide by 0. So I'm going to have a denominator here if I write this with a positive exponent. So anytime you have those negative exponents,